Okay, so let's talk about the Orion BMS 2 and how I have it set up for this system. I have 6 Tesla S batteries, and they each have 6 cell taps per battery with a total of 36 cell taps. This is something you have to keep in mind when ordering a BMS system, especially from Orion, because depending on what battery you have, you can have more or less cell taps, so you have to choose the unit size. I think Orion can go up to 108 cell taps, which is quite a few. I would hate to try and wire that up. This one was a bit of a pain in the ass at 36. There is a nice computer generated or wiring diagram generator for you when you're choosing your system that Orion has. It's very handy. I would suggest you use that to help select what unit to get and where your cell tap plugs will be divided. This is a very important thing. I'm going to try and explain this the best way I know how with a simple wiring diagram. But if you look at my cell tap plug, my first one here, so this is for my 2 batteries, 4 I should say, and these are all the cell tap wires for these ones. And something that's very important when you're looking at the plug, my very first set of wires for the cell taps comes into battery 1. And we started at the most negative post of the battery. So this battery 1 is the start. This is my negative terminal right here. And that actually, I have a connector back here for it. It's just not plugged in right now. But that goes to my inverter, and that's my most negative side. So we're starting here, and then we're going to be going up, as in positive, more voltage going up. You'll notice this connector each has 3 different color-coded wire systems. And you're probably wondering why I don't have this third one used on this single connector here. This is something that's very important to consider, and it's a pitfall if you don't really know what you're doing. So I'm going to explain it because their manual is kind of difficult to understand for someone that's doing a DIY project. I actually have this connector for my back battery and this connector for my front battery. And notice it doesn't even come fully pinned out, because when you select your unit, it will come with enough wires for the cell taps. So I have a 36 cell tap system, and that's all this unit comes with. It doesn't do more, and you don't have to use it all, in other words. I'll now show you a program. Okay, so here is our Orion BMS software to help, or wiring diagram to help determine what or how you'll wire your Orion system into your battery pack. So I know I've got 6 Tesla cells. They each have 6 cell taps per module. So I got a grand total of 36 cell taps in series, right? The next thing it asks you is the fuse or safety disconnects. So this is an important thing when you're designing your system. You're going to want to know where you're going to put. If you have to split up your battery pack and put 2 batteries in the front of the vehicle and the rest in the rear, like myself, you have to think about this before you start hooking up your batteries. This is very important. Now, I said in my last video, cell number 1 is the most negative, right? So this is where it starts. You start at cell 1, the negative post of the battery, the most negative. For me, I have 4 batteries in the back of this vehicle, which means I have 24 cell taps. And then I'm going to start my next cell tap at 25, which would be at the front of the vehicle. So there's going to be a split or a disconnect. In my case, the disconnect is my relay. I am separating the front battery pack from the rear battery pack with a high voltage relay. So that's where I'm splitting my pack. The next thing it asks, and this is just a rule of thumb for cell tap wires, because you have changes in voltages and they have to be very very accurate. They're sensitive. If you got slight resistances, you're going to get improper readings from your batteries. So obviously my BMS is at the back of the vehicle, but again, my 25th cell tap is going to be at the front of the vehicle, which means my cable is going to be longer than 3 feet. I'm at least 6, 7 feet away from the Orion. So I put that in the system. Once you've selected what you want, you can generate the diagram. Let's see what it says here. So this is how it determines what you're going to need. Recommended BMS size, 48 cell BMS. So now I know what style of Orion to order. It needs to be an Orion with 48 cell reading. I may not use them all, but that's the size that they require. So if you look over here, here is the plug for wiring, and it's very nice because they come labeled and numbered. So we're talking our first group of batteries. So starting at our most negative cell tap, that is where our first black wire down here is going to go. It's our first connector wire. Number one. We'll run that to our cell tap on the board. Now our Tesla boards have a cell tap board that's installed, and it's all labeled nice and neat. So there is a negative terminal that I can crimp a wire on and plug it in, and then vice versa as I start building it up, right? Now, don't be confused. There's two ones. The one has to start at the most negative terminal, then you count upwards, right? So with our very first wire going on the very first battery at the negative post, basically, or the negative cell tap on the board. You can do either or depending on your scenario, but if they have it on the board, use it just to keep it simple. Then we have our very first cell tap wire, number one on battery one. So if you look at this diagram, we got 1, 2, 3, 4, 5, 6. That's one battery right there. We just did one battery, and now we're going to do the battery that's immediately below it, and we'll just count up again. 1, 2, 3, 4, 5, 6. We've just wired 2 batteries. Now this is where it gets a little bit tricky, because we're at the last cell tap on the second battery, and see this terminal here, negative 13. That's a black wire, so that needs to go to a negative portion on the battery. This is where it gets a little bit confusing. That negative wire is not going to go on the second battery. This is where I had trouble. That negative wire actually goes to the next battery. So this is battery number 3 now. So it starts off the negative wire on battery 3 and count upwards from there. So that's just a negative reading. So we're on battery 3. 1, 2, 3, 4, 5, 6. Now we've just wired up battery 3 all the way to the end, and we keep going. 1, 2, 3, 4, 5, 6. There's all 4 batteries right here, all with all our cell taps on. And notice how they pin 25 NA does not get used. That first connector that I just showed you, none of this gets used because of where my fuse location or circuit disconnect is. So this is our first connector on our Orion. The rest of the wires you can chop off, or in the manual it tells you to wrap them together. That's something I would read a little bit more on, just so that the system knows that those cells aren't being used. So we've got 4 batteries here. We've got 2 negative pinouts on those 2 batteries. I'll show you that in a second. And then we've got batteries 5 and 6 at the front of the vehicle. So my very first battery, I'll put a negative wire on that. So battery 5, 1, 2, 3, 4, 5, 6, and then our final battery. And I do not end with a negative terminal. Here's my negative. So this is the start of my battery and my wiring. And as you can see, if we look down at our first cell tap, there is 6 orange wires. There's cells 1 to 6, my first battery. And you'll notice that there is there's my first negative wire on my cell tap board, that black wire. So there's my most negative. It'd be like being on this post here on the battery, except for they have a cell tap on the board. Those other 4 black wires are actually for the temperature sensor, and each battery has 2 temperature sensors in it. You can see those 2 yellow wires down there go to a probe that's on that side of the battery, and there is a probe on this side of the battery. I don't know if you can see. There'd be a blue wire somewhere down there's the blue wire. So each battery has 2 temperature sensors on either side of it. Okay, so here's the best way that I found to explain why you have to choose where your disconnect or fuse or relay is when wiring up your system, why the wiring diagram generated or asked me those questions so that I could choose where to put the cell taps. Because you notice my first connector, this would be my 2 connectors on my Orion. My first connector, I only used like 3/4 of it. And you wonder why do they do that, or what's the reasoning behind it. So if the simplest way I can put it, if this is our battery, I'm just going to draw the battery as a line, right? Here's our most negative post at 0 volts. Halfway down our battery, we're at 72 volts. And all the way at the end, the positive end, we're at 144 volts. So power is always flowing to the right. Let's just say that. The way the Orion does is it monitors each cell tap wire at different stages in the battery, right? So if we think about it, we have a cell tap wire going to each section of the battery, right? And now they asked where I was putting my fuse or disconnect. Well, why do they want to know where that's going? And for one simple reason, right here, and this is the logic behind it. If we have an issue, say our fuse here burns out, you can think of our cell tap wires on another bar, right? And they're all joined together technically. If our fuse opens and we watch where the voltage goes, so it's traveling down here, right? And it gets to the end, and that voltage can't go down any further. What's it do? It finds another way, right? So then that voltage is going to come down this little tiny wire along here and back up this tiny wire and then continue on. Well, we have a huge problem there. This is a 144 volt system. Those wires, which you've seen in my other video, they're tiny. What is going to happen the second high voltage hits those little wires? They're gonna melt. They're gonna pop fuses or melt your entire harness. That's why the Orion doesn't want a connection in between one of their plugs. So we'll put our fuse back and we'll do it the way Orion, the wiring diagram has generated it for us. So let's see what happens when our disconnect is in between the connectors. So if I have a problem, a fuse, a disconnect, whatever, right there, the system shuts off or the fuse blows, we follow our voltage. It goes and stops right there. It can't go through this bar and end up at the same location, so nothing's going to happen. These two plugs or bars inside the module are not connected to each other. There's no way for voltage to get going back through the module to the other side. That's why they want to know where your disconnect or fuse is. You cannot have it in between a midsection on a plug. So in my case, I have 36 cells. 36 cells. My wiring diagram told me that I needed a 48 cell BMS. And that's because I can't put all my cell taps on one connector depending on where my fuse is. So the Orion that I needed had to have two connectors. You can see on my video the majority, 3/4 of the first connector was used. And then I break my battery pack and the last two batteries go on my final connector. That's so that when I have, or depending on where my fuse location is, I can't run into any of these issues like this. No melting wires. I mean, they have 36 cell taps on one connector. If I didn't have a fuse anywhere in here, I could have an Orion system with one plug and every single cell tap on that. But you should try and break down your battery pack to lower voltages or try and isolate things. So that way if something shorts out, you don't have a huge potential of energy to run away on you. Okay. So we've got all our cell taps on and our Orion wired up. Let's take a look and see what it's seeing with our cell data. I'm just going to connect to it here real quick. So when we go over and we look at live cell data, what are we looking at here? And as you can see, here is all of our cells, starting with the very first cell. Now, see how they're all reading the same voltage? 3581, 3581. So there's 6 cells. That's one battery. And repeat it on. So there's 4 of my batteries. And look at, there's my break between my between the 4 batteries in the rear and the front. Now take a look at this. They're all very close. 3.5, 3.57, right? Now let's take a look at my front batteries. There's 2 batteries here, so 12 cell taps. 3.6, there's a slight change in voltage. And that's because, and that's another reason why the Orion asks you how long your cell tap wires, right? They want to try and keep everything the same. We look at our lowest cell voltage, right? And our highest cell voltage and our lowest, right? It's measuring. And we can look at my battery pack state of charge, 47%. And we're looking right now, my pack voltage is 129.6 volts. So this is everything. This is all of my cell taps and my total reading on this pack as it stands right now. Okay, let's take a look. We're going to throw the charger on it. So this is my charge port, the original location where the fuel fill would be on this car. I just hooked it up. Takes a second. Charger's going to flash green. You'll hear my fan running. And we're going to go back over to Orion and let's take a look and see what it's doing. So we're going to connect back to it. let's go to our cell data. Okay. So here's a key thing to note. Let's grab a pen here. The voltage right now, negative 14 amps. So when charging this vehicle and the Orion system, it shows up as a negative. It's kind of weird. I'm not sure why. It's some sort of engineering thing, but it shows up as a negative, and then power coming out of the battery pack shows up as a positive. Maybe just engineering for consumption. You can see right now my voltage is going up. If we take a look at each cell, they are pretty damn close. And this thing is monitoring. So remember our cell voltage, there was a minimum and a maximum voltage. We don't want to go over that, or we'll cause one of these batteries to be unstable or catch on fire. So this BMS is monitoring my entire battery pack, every group of wires in there, to show you or balance so that your voltages don't go any higher than they should. It's also for diagnostics. So if I had a bad cell number 6, this wasn't reading correctly, I would know that on my first battery, 1, 2, 3, 4, 5, the 6th cell tap wire is either shorted out, which I hope not, or there's something wrong with the battery itself and the cell's bad. So I may have a bad battery, but in this case, everything's reading the same. These are all the cell taps that didn't get used on that first connector, and there would have been 12, right? Because the first connector could hold 36 wires, but the way this system's wired up, I cannot use that. So, if you're just looking around, now they're pretty damn close for highest and lowest cell voltage. This thing's going to want to try and get it as close as possible. One of the unique things that once I get to a higher voltage on each cell, this Orion BMS will balance them. So if it sees one starting to get higher, it will, right here, red cell background indicates cell is balancing. It will shed the voltage or put a load on that cell to try and bring it down so that we can keep them all the same. You want all your battery voltages to be exactly the same. So when you're using power, they all drop at the same rate. Because if out of this entire pack, if I have one of these drop down to 2 volts, well, that's it. That one cell tap's going to shut down the entire system. One of the cool things that I did, just so I know when I am plugged in and charging, I put a light system in. So the second it is plugged in, the lights turn on, and it tells me that the system is charging, that the Orion detected the wall charger. Just a kind of handy feature to let me know everything is working. And that the actual system turned off. So it's really not that complicated. What you see here is basically the majority of the electrical system on this car. A BMS, an inverter, and a charger, or onboard charger and alternator, if you want to call it, all in one. And the battery pack itself. So not that bad. It's not that big of a deal to try and convert something. Where the real struggle is, and we'll get to that, is actually this. Trying to mount the motor onto an original transmission, or there's many different methods, but this vehicle's never been done before, so this is currently where I'm at. So I've already got, this would be like my crankshaft or hub. This is my clutch. It's an aluminum flywheel. We've taken off the ring gear because there's no starter in this. It machined it down. I do have the plate for this, and I have some spacers that I will space this motor out from, and bolt it to my plate. So almost there. And this little tranny, we will see if it will hold up to this. Obviously, this guy's no good. Another issue with this Lotus when I got it, someone let the tranny fill up with water, completely destroying it. Good news is I actually do have a transmission in there. You can't see it, but it is in there, still bolted up because it is a part of the suspension.